All right, so quickly going over this question in modulus and argument. So prove by mathematical inductions that z1 times z2 times z3 times z, like all the z values up into zn, the absolute value or the modulus of that equals the same product if we multiplied it in parts of the absolute value for all these complex numbers. So in this one here, we first step in any proof is we need our first step. So we're looking at n equals 1. And in this one here, we would have z1, which is the left-hand side of this problem. So that's using this form, our first term. And then we've got z1 in this space equals our right-hand side. So this is not really a proof in that one, but P1 is true. And that's our first step there, even though this is actually like we're stating the same thing. We haven't really done anything then. So our next step is if Pk is true, then we would have Z1, Z2, Z3, the product of that all the way through to Zk will equal Z1, Z2, Z3, oh, sorry, my writing, all the way through to Zk, and it's split into individual moduluses. So now we go to n equals k plus 1. We're looking at this one. So in this step here, we're going to have, well, this will be Z1, Z2, Z3, dot, 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 Zk, and then we've got Zk plus 1 because we're going in one bigger term. Okay, so this here is now going to equal, I'm just going to put it in brackets, Z1, Z2, Z3, all the way to Zk. Now you'll notice that's our original term there. All right, and then our term outside this is going to be Zk plus 1. We'll finish with the modulus. And then our next bit here is we're going to break this into two steps. So we're going to have Z1, Z2, Z3, dot, 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 to Zk. And that, we've now broken this into two absolute values. We've split the Zk plus 1 out. We need to state our rule here because we've actually done a rule which is Z, the absolute value of two complex numbers, the modulus of two complex numbers equals the two complex numbers multiplied together. All right, and then we've got, in this next one, we're going to swap out Pk. So we're going to have Z1, Z2, Z3. Oh, my writing's getting worse. Zk, and then Zk plus 1. And this is because Pk is true. Oh, is true. Oh, let me erase that. All right. So we've got to that, and then we've got to put in our sentence here. Since P1 is true and Pk plus 1 is true whenever Pk is true, then our proposal Pn is true for all n, all positive integers. Sorry, this is actually our Pn up here. I didn't specify when we were doing that. Okay, cool. So our next bit goes, hence prove that z to the power of n equals, with the modulus on the outside, equals the modulus of z times to the nth power. Now in this space here, you're pretty much looking at this bit here is going to be z times z times z times z times dot 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 times z, and I'm just going to go here, this is n times, okay, which means that this is going to equal, the modulus of this is going to equal z to the n, which equals which if I so I've just broken this out, this is actually going to then mean that we've got sort of Z1, Z2, and I'm doing this the wrong way around. I'm trying to explain this, but this one, it's a bit of a bizarre one. Z2, Z3, ... Zn. You're looking here at these. Z1 is equal to Z2, which is equal to Z3, which is equal to Zn, which just equals Z. And so then in this space, that means that Z to the n has to equal Z to the Zn, like that. Yeah. I feel like I'm explaining something really simple but struggling to put that together properly. Anyway, so that's pretty much what we're saying here. Because we've got this rule where it says that we've got these complex numbers up here, and when we had them all inside the power, like we do here, that means we can apply this rule and we've got it right there. So the final bit is we're looking at Z to the 30 and we're given a value for 30. So we're looking at the modulus of 3 over 4 minus I to the power of 30. And if we can change this and we go, well, let's use what we learned in the question before, and we go, well, let's go 3 over 4 minus I to the power of 30. The modulus of this is going to be 3 squared over 4 squared minus I squared. All right, this is going to give us square root of 9. Oh, sorry, that should have had brackets around it. 9 over 16 minus plus -1 squared. That shouldn't have been I, that was a mistake on my part. I was just, so plus -1 squared. So that's going to equal the square root of 9 on 16 plus 16 on 16 equals square root of 25 over 16. Now, so I should have kept my 30 over the top. 30, 30. So this is going to equal the square root of 25. It's going to equal 5 over 4 to the power of 30, which is going to be approximately 808. Thanks, guys.